Welcome to this session, which is about building LLM workflows in the Wolfram language. I'm Giulio Alessandrini. I'm the manager of machine learning, and with me there's Timothée Verdier, who's a senior developer of machine learning at Wolfram. So this is a quick outline about what we are going to show you today, how to build, and it's not just rewriting it. Our hope is that we can build this together and we can actually help. I'll be speaking and Timothée is going to be helping under the hood to make sure that nobody has issues. So let's first make sure that everybody is properly set up. So this is a talk about LLM functionality. So in order for this to work, you need option 1, an LLM kit subscription. Option 2, bring your own key. So if you have a paid subscription, or in general, an API key to an external service like Anthropic, OpenAI, Gemini, but also like OpenRouter, or like we have a bunch that we support, Qwen, DeepSeek. You can use that, and you can use your own plan. And option 3, if you have a sufficiently powerful machine, mine is not, for example, you can use a local LLM by our Ollama connection. We are going to show like more of these in detail if there's a need to. So the way you set it up for the whole system without having to mess up individual function calls is opening the Wolfram settings, the preference panel. You select the third tab, AI setting, and here you can either subscribe or check the status of your LLM kit subscription, or let me bring it up. I hope you can see it. Yes, this is the preference panel, and I'm set on Wolfram, but you can set, for example, OpenAI, or you see Anthropic, Gemini, Aleph Alpha, Cohere, DeepSeek, Grok, Mistral AI, Together AI, XAI, Ollama, OpenRouter. So like any of these you have will be, I don't want to say equally good because they have different models, but yeah, I mean, they will make it doable. Now, how do you make sure that you are set up? Well, let's do the LLM synthesize test. So right now what did I leave it to? I moved it to OpenAI, so let's put it back to Wolfram. So I'm using the Notebook Assistant, plus LLM, we care about the second part here, the LLM kit subscription, which gives me access to LLM through Wolfram. So you see that I run this and I automatically get a result. Now, if I select in the preference panel a different model, like let's say Anthropic, oh, this is what I get for using development builds. Let's reset. There it is. Okay, so let's use something like fast model, Haiku 4.5. I select this, and we slowly go in there. And now I run this, and this should run using Anthropic answer. Yes, so this is waiting for Anthropic, and okay, the answer the same. Yes, it standardized it. So yeah, in general, like any of these is supported. So please, I encourage everybody to try this because if it doesn't work, we cannot even start. So you can let us know in the chat if that doesn't work. So I'll wait like a few seconds so everybody can test this. If you selected a service and you never use it before, you get this out. Don't be afraid. This is a normal splash screen where you can put your API key. There's also a link to the page where you can get the credentials if you want to buy them. And this box will basically save those in your cloud account. So it's not that we save it, we cannot see it, but this way you will be able to access them through your cloud account in any machine, basically. Okay. I see that there are like some question being asked. Oh yeah, I mean, if you want to check what's going on, you can use the LLM evaluator property. And I don't know why this presentation thing is very slow to type. And you see that you get back the LLM configuration that was actually used. So, okay, my slowness on my front end didn't fully switch to 4.5, but this is telling you this is Anthropic, and this we're using Claude 3 Opus. So yeah, you can always do this, and you can see what's going on. Okay, so let's see if I can go not full screen and probably be slightly faster. Toggle full screen. Okay. Oh, this seems to be a lot more responsive. I'll still go big, so you can see everything here. Okay. Now let's go to the core of our presentation here. What are we going to build? So we thought a bit about that, and we decided let's build a chatbot. The chatbot. That's typical use case. A lot of companies are doing this right now, and it's nice because it allows us to go through a variety of technical instruments and tools, and basically show like how you can orchestrate them all together. So for this, I decided to pick the Whimsical Wonders Limited company, which of course doesn't exist, just because it offers enchanting and whimsical products like the Magic Bubble Blower or the Rainbow Maker. And so yeah, this of course doesn't exist. You can imagine that there's your own company here, or like you can have fun and create your own fantasy company for this talk. But I left all the outputs and the data in the slides, so if you just want to follow along, you can just evaluate stuff and try that it works. But you are strongly encouraged to play with the code and try to do things. Now, how do we make these chatbots? Well, let's think about like first thing, you get a user in and you have to create a message. Yeah? So basic form is we use the LLM synthesize function. LLM synthesize, as I was showing the test before, will take like some text and it will generate an answer, or like not really a continuation anymore, but yeah, these are all models trained for conversation. So it will generate like the next step in the conversation. So for example, here, I'm putting all the prompts in variables, so it's like easy to reuse them. But if you just want to play with it, you don't have to. I say like generate a friendly greeting message for a customer service chatbot. And so just showing that this can be selected, and if I run this again, it will do. Okay, I'm still on Anthropic. Probably want to switch back because I haven't tested the whole presentation with Anthropic, but could also go wild and do this. So this one is typical LLM style with emojis and things. Of course, this is just basic. This shows you how you can kind of prime an LLM to assume a specific role in a conversation. In this case, it's pretty spot on. Like is actually pretending to be a chatbot. Like it's acting as a chatbot, and of course this is completely unrelated to our company and the topic. I mean the actual content that you want to present to the user. Yeah. So this is just like a little more than a blank slate. How do we make this more interesting? Well, we need at least to give it an idea about what our company is about. So here I wrote a little bit of a description, like what Whimsical Wonders is doing. This is a fantastical company. It has enchanting products. I'll give a couple of examples. I mean, like all in all, like it's kind of a blurb that you could find in any like about page for any company. So now I just plug in this in a list, and this becomes basically, under the hood, this becomes a multi-part message. So my user here, like the user role, if you're familiar with LLM terminology, will have like this is, it's up to the LLM provider to decide what to do with this, but it will be likely concatenated into a single message and handled by the LLM. Okay, sorry, my references are acting weird here. Now what's going on? So basically, let's run this and try it again. Now, okay, so the LLM, okay, now the LLM is taking that into account. Yeah, so the role, like, there's a good principle here, which is like put the important things that you care about in your prompt. It can get very big at the beginning and at the end, so that I mean, we don't know much about the theory behind how transformers work internally, but we have done a lot of experiments, of course. So like experimentally, the attention mechanism pays more attention to stuff at the beginning and at the end. So like let role, for example, be at the end here. So like it's very clear that this has to be a chatbot. But now you see that the text is more spot on, and this is like a better form of greeting because it relates to what our company is fictionally doing. Now, yeah, I mean, this is quite boring. This is only good for a greeting. In general, we want something that answers questions. Yeah. So let's just move to another function, which is LLM function. Now, LLM function is not much different than LLM synthesize. Is just packaged differently. You know, it's packaged in a way that makes it more convenient to have like an LLM prompt that is input dependent. Yeah. So in this case, it is built on top of string templates. You know, this double backtick here means like, you know, there's an implicit one here, like first argument, and this is the argument. You know, there's a very angry customer that has a broken rainbow maker and wants the money back. Yeah. Now, what we do here, we still use the option. No, still, I mean, we were putting everything in the prompt before. Now we use an option to kind of save the main prompt for the user message, and we put all the rest as like system developer, depends on the API, you know, like kind of initial messages that will set the tone for the conversation. Yeah. So to do this, we use the option LLM evaluator. You can set several things with this. Yeah, we're not using it much in this workshop, but you can set like the temperature, stop tokens, max tokens, the model that you want to be used, and all sort of like reasoning effort if you have like a model that supports reasoning. So yeah, I mean, you can set all sort of things using this option. Right now we are using it to set initial prompts. Yeah, so we're putting the description and the role in here, and we are reserving the main user prompt to get the customer message. And you see here that now this response is tailored towards what the user has actually written. Like, let's imagine that this, you know, we hook it up to a chat window. So yeah, like this is actually able to answer. Now you can, you know, I wanted to keep it simple, but you can play with this. You know, like let's say that you want the LLM models to start with something, like to follow a specific pattern in the response. Like you can put all sort of things here. You can make this prompt longer and richer. It's a bit of trial and error, both because, you know, you don't know how each model will react to the prompt, so you might optimize a prompt to a specific model, and then there's the fact that, you know, you change model or the model is updated and it acts a bit differently. But in general, like if you are clear and descriptive about what you want, these models will try to oblige and follow patterns as much as they can understand it. Now, this is, like, it's a bit more interesting because it's now like starting to become like conversation. But of course, we are dealing with toolings here, so we can do more. We can customize the prompts with external information. Now, how can we do this? Well, we can use the whole Wolfram language to like create and package as much stuff as we want. Yeah. So like imagine that we have like here I'm like symbolizing like a query to like a database query where we get a little user user metadata here. So what we have here is like the username, and I'm using like these dollar variables. You can put like strings in here, but I'm using the dollar variables, so like this automatically gets my stuff, and I can show you. Like, see, this is I think it's geolocation city is going through my interpreter. So the first time you run it, it's taking a bit. Yes. So this is my name. These are the two products that I bought. This is my current daytime. Location is fake because it's going through VPN. I'm not actually in Champagne. I'm in Rome. But I mean, I could force it. For example, let's see that we change it and I say Rome, Italy. This should, yeah, perfect. Is this Italy, Rome? Yes. So now it knows where I am. Okay. Now, what do we do with this? We package this in a function that takes, like I'm using this kind of method system. So to pass a user prompt, and now this thing here is a function that can be applied to a context. Now, this system is more generic than what I'm using it for now. It can actually enrich this information using what the user has written, and I can tell you some ideas about how to implement stuff with that later. But right now I'm just ignoring the context and just providing flat information, which is information about the current user in the chat session. Yeah. Now if I define this function and I put it inside what is called LLM prompt generator, I get basically this. LLM prompt generator is a function that allows you to generate basically prompt bits on the fly. Yeah. Now this doesn't really depend on the context, so I can put whatever I want here. But for example, like if you've seen like bots on Telegram or things like that, where you can have you can add all sorts of special syntaxes, like like /info or like orders, and this allows you to basically inject custom logic that you control. Yeah, this is nothing about an LLM here. This is a completely functional pipeline that you control. That right now I'm using to inject user information, but you can use it to transform the prompt in any way so that the LLM sees what you want it to see. Now, I mean, I hope this works for everybody. You can feel free to customize it and put in whatever you want. And how do we actually plug it in? Yeah. Now, I'm going back to my prompt here. And I'm adding some extra information here. So I'm creating a new piece of a prompt with a name, and is like use as much the customer information as possible to make the conversation more personal. Add the user by name and use a proper greeting, even the time of the day. You can, of course, customize this however you want. This is just to make sure that the LLM is using the information, because in general, it might choose to ignore it. So if you want to be a bit more certain that this is used, then like it's always strictly better to put instruction about that. Now, this will be put in here. So we have description, role, custom info, and here I put the LLM prompt generator. Yeah, so like this thing here is a function, but will eventually return a prompt. So I just it just fits naturally with the list of prompts here, yeah. And then you can experiment. I didn't experiment much, but you can experiment with the order to see how different orders here like will give you different results. So now let's take the same message from before, and let's see what Anthropic is saying. Okay, so dear Julio, good evening. So like you see that this is, but it's not really rainy, so you have to pay attention, because these LLMs tend to be, to be people pleaser and go above and beyond. But or maybe because I said it makes it rain, so it infers that it's raining right now. So see, in this case, let's not bother too much about the rest of the message, because we didn't give the LLM any information that, about what actually we want it to be written inside. But we see that we're working on a greeting, and the greeting is much better now. Like it knows about me, it knows about the product I have, and it can be used. And you can imagine that if like for reason of like time and space, I didn't put too much in here, but you can imagine that this database query could return an arbitrary amount of things, like past tech support interaction, and like open orders, stuff that is under delivery status. So a lot of questions might be answered already by providing good context with this system. And again, you can suggest to use like specific keywords that you can intercept and handle yourself, even before the LLM gets to have a say in that. So yeah, at this point, we have you've gone from like a generic greeting to a more personalized message that is based on what you've written and who you are. Now, I said before, the content of a message, beside the formality around it, is still very much up in the air. The LLM is completely free to say whatever they want. Now, how do we fix that? Well, the best way is to provide information ourselves. Yeah. So like here I created like some FAQ. Like these are just a list of you can see it here, question and answer pairs, and another piece of prompt. So okay, it's too much. Another piece of prompt is if relevant, uses FAQ to help the user. So this is also an interesting bit. Like you can experiment with stuff like this, because like some LLM will try to use stuff no matter what. Some will not use it. So yeah, it's also just a matter of finding the right mixture of use it when it's important, but not feel compelled to dump the whole information content on the user at every message. Yeah, they can be easily verbose. So yeah, this is also like a good thing to experiment on. But yeah, this is creating like I put here in the pane, so you can actually scroll through it. I just think I had like 14, 15 questions about tracking order status, and so very whimsical, like the company name. But yeah, this is completely free form. So okay, what do we do here? We keep growing our prompt list, description, role, custom info, LLM prompt generator with the user, and the FAQ prompt. Yeah, we're dumping the whole FAQ into the prompt. Yeah, now we run it again, and what we see is, it'll take a bit more time to process this. Okay, so this is the thing that you don't want to see. Yeah, so like you want like a bit more railroads, but like don't mention these kind of things. So like this is really model dependent. Like I think if I go to a more recent model, probably they are like a bit more trained not to do this. So okay, let's try again using LLM Kit this time. Okay, so this one was better. So in this case, it talks about the guarantee that we have replacement or refund. and then this is very good because we want it to give good, correct information, not like made up stuff. So okay, so I have a question. Why did you include the string riffle? Oh yeah, this is just the way I wrote it. I wrote this as a list of question answer pairs, and string riffle is taking this. It's just a structural thing. It's taking this list of string elements and compacting the list into a single string using, I think I put a double new line. Yes, using a double new line in it. Yeah. So I make this list into a single string, and then I join it with this other string. So I get this at the top. And yeah, okay. So yeah, I mean, this still, there's a bit of variety here. If I rerun it, probably get something different. Sometimes it's picking it up like email address, but all in all, like is kind of sticking to the plan, is mentioning the guarantee, replacement or refund as it was written in the FAQ, and is kind of like try to engage in conversation. So like it's going in the direction that we want. Now, what's the problem with this strategy? I mean, this seems to work. So why should we move away from this? Well, because like this FAQ prompt is just a stand-in for the complete knowledge base of our company. Yeah, it can be tens or hundreds or thousands of documentation pages, and imagine that you also have access to the past tech support interaction with tickets, email exchanges. You can have all sorts of things that are relevant to this conversation, and you cannot really dump all of them in the prompt like I'm doing right now. So you need a better system that will kind of automatically take care of including what is relevant. Well, luckily we have a solution for that, which is semantic search. Now, oh well, I didn't mention what RAG is. RAG is retrieval augmented generation. Yeah. So now basically we get information and we augment the generation process by the LLM with the retrieve information. Now, before I was really like dumping everything, but this time we try to do some real retrieval. Now, what can you do? Well, first I'm kind of doing this to delete every index I have. Like semantic search index is basically storing vector pointers, like it's called vector embedding. Technically, is a vector representation of textual content, and the basic idea is a sort of like nearest neighbor search, where when I put some new content, it will be embedded in the same vector space. Then I can do a like efficient nearest neighbor search, and this will point to pieces of text that have the same like semantic content of my reference. Yeah, so the user asked about refund, it will hopefully find bits about refunds. If a user asks, the previous interaction, we'll find bits about the previous interaction. So it's all a matter of, like finding the right context. So this is to show you how you can create this on the fly. Like this is very fast because I have only 14 elements, but this system is built to scale. You can store, tens of thousands, millions, tens of millions of vectors. And then this suddenly becomes way more interesting because all that information is stored on disk and is accessed quickly on the fly. Now let's see if I run this. I use create semantic search index to create it. I can give it a name or it will be auto-generated, and then I can use semantic search with the index and the user input to get FAQ question. For example, here I say like give me the first 3 relevant bits. Now, like the first one is particularly relevant here because it's about guarantee on the product, which is good because this contains the answer that we want the user to receive. Now, before we move forward, this is everybody able to kind of generate these indices and search them? Let me know if there are issues. I just stop here for like half a minute to allow everybody to do this.
Looks fine on the chat.
Okay, great. Okay, so how do I plug this in? Of course, we use the same system as before and use the LLM prompt generator and create a function that takes, in this case, the input and performs this search. But we also have like a quick way to do it. You can just dump the index directly in a LLM prompt generator, and we have some, code path that will take care of sending the input to that. So now, like, let's run it again, and this is going to the LLM, and yeah, this is still talking about this, but now the difference is that this is not physically present in the prompt when I generate it, is added on the fly. Now you might ask, what if you want to control this? And I didn't think of adding this, but I'm thinking about this now. So power of live presentation. Let's see how we can do it. So we can just take this thing here and plug it in and put something like input here. It's called input, Timothy? And make this a function.
That's inputs.
Okay, so at this point you can see, like, you can put arbitrary, like in this case is really input dependent, unlike the user, which was not input dependent. And now this is not using any shortcut. This is just evaluated as it is, and is an arbitrary bit of Wolfram language code. No, is not input, is just this. There it is. There, okay. So this is the same thing, it's just getting the first 3 instead of the automatic number, which I believe is 10. But this shows you how you can basically have full control on this pipeline just by converting it to a function.
It is input, but well, anyway, maybe.
Yeah. I think the default argument is input. You can ask for more in the definition of LLM prompt generator. If you want to, you can have access to the evaluator and other properties of the past conversation messages as well. Like is a quite flexible system that allows you to customize what is sent to the prompt generator. And the point is that at the end, the result must be like a textual prompt. Now, there are like nice tricks around this that if we have time, we can go back at the end. Just want to mention it. Like there's one issue with the technique I've used is that the embedding of my content, like the documentation paragraphs or FAQ, needs to be similar to what the user writes. And sometimes it is, sometimes it's not. So one fancy technique is to augment my indices using like auto-generated sentences that looks more like what the user would do. So how you do it? You ask an LLM basically to generate like text, which is like what type of things a user would say that would be answered by this, for example. Yeah, and then this is a neat way to kind of create 2, 3, 4 like add 2, 3, 4 different variations of the same kind of intent, so that you can have more like entry point to the same question answer pair, and you are more likely to hit the right question answer pair or the right documentation paragraph. Now, yeah, we can look at this in detail if you have time later. Now, let's see what we have done so far. We have built a dynamic prompt generator. We added personalized responses. And we added smart knowledge retrieval using semantic search. Now, what do we miss? Well, complex conversation need like a lot more, like specialized handling for like different intents. Like you at one point you want to have like custom path. Like, does the user want a refund? Is the user just chatting? Do they need help with something? Do they want to talk to a human? Or like, you can imagine all sorts of things. And basically, you want to be able to handle these different paths. You want to be able to make decisions based on what happens during those paths, and you want quality control. Like, you don't want to leave an LLM completely on its own. And how do you do that? Well, we are stepping up in the complexity of the task. We need to step up in the complexity of the instrument. So this is where LLM graph comes in. Now, let's see. LLM graph is, and I put a link to the documentation to like basically all the functions we're using here. LLM graph is basically able to connect different LLM calls in a graph, hence the name, and we can have like great customization on what happens in the nodes of this graph. So let's, without further ado, let's see. First, we need to package everything we have done so far in individual LLM functions that you can use on the graph nodes. So most of the things we did are already functions. I think only the greeting message was started as a LLM synthesize call. So let's create a greetings function. This needs no input, so no templates load here, because this will be used in the path where there's no user input and is the first message in our conversation. Let's see, there are questions about this. I don't see anything. Okay, so let's go on. Now, let's build something new now. Response functions. So for this, I've decided to create 3 different, let's say, personas for the LLM. One is a conversationalist. This will handle friendly chats. Then we have the helper that will answer when there are like information requests. And then there's a firefighter that will handle complaints with extra care. We don't want to like jeopardize the relationship with users. So of course we need a prompt. Like, everything is done by prompt in the LLMs. When you want to prime them to follow some directive. So the conversation prompt would be like, you're a friendly conversation partner, helpful assistant, and your usual blah blah. Answer the user, being respectful and polite. Now I will take this conversation prompt and dump it in here after the description of the company. So the LLM will know that we are like what company we are, and we know like how it has to behave. And then we have the custom bit of information about who the user is, and after that we get the actual body of the function, which is a customer message. So let's define this. Now let's define the helper. The helper is assist the user with answer from our knowledge base. If an answer is missing, suggest to contact support using the button. Like here, we're not actually doing the button here, but this is to show that you can, like kind of suggest like different type of interactions that we have built in our UI. And what I'm doing here is in the prompt list, I'm keeping the conversation because I think it's fine, and it still have to be friendly and polite. There's nothing against that. But now at this point, it should know that it can access the FAQ of the knowledge base and give answers. So I'm also adding, to make this possible, the LLM prompt generator using the index, the semantic search index built on the FAQ. And now, extra polite, if you have an angry user. Now we say the user is particularly angry. Make sure to reassure them and let them know we are here to help. And so this will, if we perceive an intent in the user, we give a different intent to the LLM and to steer the conversation on a certain path. Now, this is just definition. Let's actually test them, and can actually see them one by one. So, hi there, what's up? And the conversationalist will hopefully answer nicely today. Yes. Okay. How can I assist you today? Blah blah blah. Like generic questions to keep the user engaged, but nothing specific. No reference to our material. Now, if I run the helper on something like where's my order, it should hopefully look into the. There it is. Delivery beavers is what I put in the FAQ, and they send you a magical tracking scroll. That's perfect. They are following this to the letter. They are also, okay, this is nice. I added Rome, so they are adding the location. And they are following up with the proper thing, like contact the fairy godmother team at support.whimsicalwonders.com. So this is using like 2 pieces of the FAQ together with the prompt enrichment that I've done from the my name and my location. So yeah, I guess this is perfectly in line with what we want. Let's try I want my money back user. Yes, now the tone is a bit different, is more empathetic, and it's still offering the mentioning the guarantee and talking about the email. So in this case, we had the same kind of informational content as before, but we have like 3 different personality that we have like injected into the chat. Now, how do we detect the user intent? Of course, the best thing is to create a custom LLM interaction to do that. Yeah. Now, the advantage is that you see this LLM function is about classifying the intent. And just before we look at the content of the prompt, see there's nothing else here. This is very useful because this LLM will have an easier life to follow a simple instruction than a complicated prompt. And one advantage of parceling the inputs is that we are not confused. We are minimizing the confusion in every call. Yeah. So here, what has to be done here is nothing to do with our company. What it does is more generic and is classify the intent of this message in one of information, complaint, or chat. Yeah. And I'm specifically asking here only answer with one of the tag and nothing else, and putting the message in. Yeah. So let's define this dispatcher and test it on, let's test a new on like the 3 messages from before. So we have, you see like the pop-up appears 3 times. We have 3 calls. Okay, this is correct now. Hi there, what's up is chat. Where is my order is information. And one in my back is complaint. Now, if we test it on something new, we might see, for example, well, let's add a few lines here. How can I contact your company? Information. Okay, this is correct. Now this is, like I don't, as you can see, I don't need any customized thing here. We don't need who the user is. We don't know who the user is or what we are selling to be able to do this. So now we leave it completely out of this specific function, the dispatcher. Okay, now we have enough elements to start building, the first version of our chatbot. We have greetings, we have the dispatcher, and then we have like 3 different roles. Let's try to put them together into a workflow. Okay, first graph: greet, classify, respond. Now this is not a full graph. I'm starting with the partial graph because I don't want to overcomplicate things, but let's try to go through this piece by piece. Now we're building a dictionary, like an association here. Keys are node names. This is like a particularly simple form of graph. And And on this side, we have associations basically saying what we want. Now you have like several possibilities. You can use LLM functions or like normal functions. We are not going to use it at this iteration. So we just put here the LLM functions for before. You can put an input if you want to manually specify what the input is. So in this case, I want to force it to work without any input. And you can specify a test function. So this is already some extra complication in gating. So what I'm saying is use the greeting node if the input is the empty string, and use the dispatcher node if the input is not the empty string. And then what I'm doing is like adding a final node, which is only one of the three that we have, is this conversationalist. And when I say use the conversation node, which has a conversationalist LLM function, and this is basically checking that the dispatcher has run. We have a string response, and that this string contains chat, which is a tag that I instructed the dispatcher to give. I'm also forcing input to be sent to this node. Now, I could write these LLM functions to have, instead of the double backtick. If I, I didn't want to complicate things before, but if I know I have to use them in the graph, I can say something like input, and this will tell the template that I'm expecting a named association input where the key name is input. So in that case, I will not need, I will automatically recognize that what the input node is. So you don't need this. Like for example, here you see that the test function, we are not providing explicitly what the inputs to the text function are. These are automatically inferred by the fact that I'm putting here hash dispatcher. And so yeah, basically just put here a brief recap of what this is doing. Now, let's visualize it. You see there's a connection from input to greetings, and this is dash connection. So this is just a dependency in the test case. Then we have a direct connection to the dispatcher and a direct connection to the conversationalist. The conversationalist also has a dash dependency to the dispatcher because it will run conditionally based on what the dispatcher says. We put a bit more like information to have understand what's going on visually. The diamond means input. You can have one or more. The circle means internal node, and the square means result node. Like these two will be returned. So actually, I haven't defined a simple graph, so let me define it and check that everything is working fine. Perfect. Now let's run it. Okay, simple graph on empty input. So we can imagine that we always prime this with some empty input. Okay, this is populating the greetings node and is actually aborting the conversation node because we didn't go down that path. Yeah, so you can imagine like a little bit of post-processing. The GUI will only show this one. Let's say that I put hi there, what's up? This goes to the dispatcher, the conversation node this time. So second LLM call. Now we don't have greetings, but we do have conversation. Now we can try something like what we had before and say, for example, how do I contact the customer service? And in this case, the dispatcher will likely say information. And you see that they are both cancelled because we didn't fill in this path. But at least we know that our dispatcher is working correctly. Now, time to branch out. We have the charts. We need to add information requests and complaints. Also, we need, we don't want, ideally, we want to handle merging of these three branches, including the fourth branch's greeting, and have a final answer node that you can directly pass to the user. before I move to the more complicated graph, have people been able to run this?
No complaints.
No complaints. Good, 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 good. Okay, now let's see how we can overcomplicate things. The first part is the same. We have greetings, we have a dispatcher. Now we have added, beyond the conversation, we have the help and emergency, where we put the helper and the firefighter. These are just copy paste, they're just checking for different tags, chat, information, complaint. And at the end, I do a different node here. This node doesn't have any condition, so I just, I can just put a function here. We have a bit of auto dispatching. If you put an LLM function or a function, we automatically populate LLM function key, or in this case, a function key. Also, I'm not using any input because this is a pure function. So we can automatically look into what are the function slot here. And this is basically taking greetings, conversation, help, and emergency, and is doing a pretty, heavy-handed replace. Everything that is not a string is sent to the empty string, and then joining. It's like a trick I was thinking about, was the fastest, shortest way to merge a bunch of things. No, we know that we'll go down one path. Everything else will be missing. If you want to be a bit more safe, we can convert missing into empty string and fail hard in other cases. But yeah, let's define this and let's look at it. Now this is a bit more complicated now. We have okay, and we can see greetings. We have a greetings that goes then, if it fires, it goes into answer. Now we have a dispatcher. The dispatcher will condition the 3 nodes, and the input will directly go to the 3 nodes. And then answer will take all 4 and decide what to do. Well, let's try it. So let's kill these 3. And we say dispatcher, conversation. Ooh. What's going on here? Okay, I think the LLM failed simply. Probably some. I'll regenerate this shortly. Let's let this run. Fine. Okay, so where's my order? Correct. Complaint. Correct. Let's regenerate this. We can then inspect. Okay. Now, okay, let's see what this is good that it failed, because we can see what's going on. So let's actually take the one that failed and go here. Like, we have different inputs. You see, you don't get the association anymore now, because I have a node that outputs a single output node that outputs oh, something I didn't tell you. I have a single output node that outputs a single string, and you see this is also have a different color and symbol. Yeah, this is like, these 5 are LLM nodes. This is a Wolfram language node. Yeah, and you can use this to orchestrate, in principle, only Wolfram language functions. Now they are like asynchronously combined inside. There's nothing preventing you from doing that. But the idea is to mix and match freely LLM functions and Wolfram functions. Now, the string is not the only output. One of the most interesting output is to get an LLM graph back. Now, this is completely mutable, so this is a new LLM graph. Let's actually run it. Okay, and now let's see. Now we can check what the results are. Okay, it was an LLM error. I am a bit sad. I was hoping to debug something more interesting here, but we can actually remove result here, and you can see that you get for each node. You can use information on this, and you get sorry, information alone, and you get the usual information blurb with the graph, the names of the nodes, the evaluator. Like somebody asked about the evaluator, of course you can get it also here. But asking for nodes is really very interesting, because you get what the input was, well, if you have a test function, like in this case, this is, this is an input node, so nothing really runs. This is just copied as is in the graph, and the result is the input itself. Now the dispatcher has a function, has a test function, and has a result, so you can inspect what happened in between. And so this one didn't run, is missing the result. This one didn't run. This one did run. And then, I need to scroll down. And then we have the answer node that is taking all of them and just letting through the correct answer. So yeah, I mean, you can do a lot of things. So like, what are the common issues that you can see? I was really hoping to be able to show an issue. I mean, test function didn't match. This is what we saw early. We only implemented the conversation path. So like, if we go through any other path, we would, get like all nodes failing. But this is very easy to see. Like we wired things wrong. Especially if you manually wire things, it's easy to make mistakes. So this will allow you to expect that. And then you can check for LM function error. Let me run it again. Let's hope this will fail. No, I'm particularly unlucky. Didn't fail. But yeah, I mean, the result in that case would be like a nice failure object with annotation about, let's say that, I mean, this is completely freeform, yeah? You can change your LLM model, and you can use, Anthropic on a node, LLM Kit on another node, OpenAI on a third node, and let's say you don't have a key for one, for example, and it just failed. So like you can check this. Yes, I see that you are meeting time.
If not only, but if you want to play wild, you can switch $allow internet to false, and this should fail.
True. Well, let me try that. I don't know what. Okay, there. Connection failure. Nice failure, and then it propagates down. No, well, actually, none of them did run. So at the end, we have the final failure.
Yeah, the failure handling is quite direct because of so many failure cases that can happen. Failure are not propagated, so you have to cure the LLM graph and carry on with the computation. That's the current status.
Okay, let me put this on to true before I forget to switch back. Okay, so we are at meeting time. But I added a bonus step here. If we had time, we don't, but you can do this at home. So should we trust the LLM output directly? Maybe not. So here I'm adding another like sort of dispatcher, like an LLM function with no information. But of course, we can add extra context that will only answer with a new type of tag, correct or specialists. Like we need a specialist to step in. Or you can say like human or whatever. And this is taking the input, you see, like with the template, with the name slot, and the answer, and it's generated one of these two. Yeah. So once I've done this, I just show you. Okay, for example, here, I want my money back. I'm really sorry. Blah blah blah. This is saying correct. I want my money back. Well, that's your problem, not mine. We say, call somebody. Now, if we plug this in and just adding a new waiting message, like Fairygram models are coming to help, and I'm plugging it after the answer, I'm just putting judge. I don't need to do anything else because it will see answer, like we just pick up names and input. And then I have output. So if string contains judge correct, fine. Otherwise, print the waiting message, and like we can add some extra logic in a real production setting to call in the user. And now we have something like this, where the judge will be the final gateway between the answer produced by the previous step and the actual answer given to the user. Okay, we are like really beyond the end. I put some extra challenges here if you want to, if you feel particularly inspired and you want to try yourself at like possible like expansion avenues, and some extra resources. How you get stuff from the documentation, our community, And yeah, of course, this notebook I use is the same you have. You can check the material here. Thanks for your attention, and I hope to see you around in the rest of the conference.